Welcome back. So we were working with inequalities. Let's go back to the question we started with. Let's recall how we addressed it. Product of factors greater than 0. Identify cut points. Whether or not this is greater than 0, greater than or equal 0, less than 0, less than or equal 0. Take each factor, set it to 0. Solve for x. Those numbers, cut your real number line, place O's, place O to indicate that those numbers have been removed. When you remove these numbers, you get intervals. Here you have 4 intervals, right? Write those intervals down. From each interval, choose a test number of your liking. Plug in those test numbers in your factors that you started with and just identify the signs, positive or negative. Here is the original expression, which is product, multiplication of these factors. So you're looking at multiplications of signs. Odd number of negatives will give you a negative. Even number of negatives will give you a positive. Now, go back to the original question. It is greater than 0. That's the requirement. Greater than 0 means positive. So you're looking for positive signs here and here. So solution set is the intervals with a union. U stands for union. You are taking more. That's the union of these intervals. Graph, just shade the region between the numbers which represent the intervals. Notice, open interval means the endpoints are excluded. Which brings us to the next question. Greater equals 0. Same story, same steps, except because this is greater equal, the intervals are closed. The endpoints are included. The endpoints are included, so you fill in those points. Okay? Notice infinity is always excluded. It's not a real number. It remains open. Okay. Now suppose instead of greater equal, the question had been less than 0. Less than 0 means negative. So you do all of the steps as before. But in the final answer, you look for negative. You want to be less than 0. So the first interval and the third interval. So when you are negative, you are looking at the first interval and the third interval. Because it is less than 0, endpoints are excluded. So they continue to be O. These are open intervals. All right. Last step, last question. Suppose it had been less than or equal 0. In this case, endpoints would be included. So negative infinity to negative 3, included, closed, union, closed 2 to closed 5. What's the graph of the solution? Include the endpoints. So fill in the endpoints. I hope the procedure is clear. Cut points, intervals, test numbers, table, answer, graph. Now here is a different type of question. You have a numerator and you have a denominator. Denominators are always tricky. This fraction has to be less equals 0. Let's start with the same idea. Factor the numerator, factor the denominator. The numerator factors as x plus 2 times x minus 1. Denominator factors as x plus 4, x minus 5. Cut points. You get cut points from the numerators. Those are called zeros. And you also get cut points from denominators. Now this is the catch. Whether or not I'm less than or equal, greater than or equal, less than or greater than, cut points are all going to be the same. This step will be the same. Okay. Once you have cut points, write them down on your number line. Notice negative numbers on the left, positive on the right. Whatever remains are your intervals. Once you have intervals, you will build a table. Intervals on the left, choose a test number from each interval. Okay. What is a test number? Any number from that interval. From interval 5 to infinity, I chose 6. You could have chosen 100. That's okay. 1 to 5, I chose 2. You could have chosen 3, 4. That's okay. Negative 2 to 1, I chose 0. Negative 4 to negative 2, I chose negative 3. Negative infinity to negative 4, I chose negative 5. Now you see the numerators and the denominator factors, they are all listed. 1, 2, 3, 4. They are all listed over here. I plug in negative 5 and find the sign. Negative 5 plus 4 is a negative number. Negative 5 plus 2, negative number. Negative 5 minus 1, negative number. Negative 5 minus 5, still a negative. 4 negatives, fraction, multiplication or division. 4 negatives get me a positive. Likewise, I plug in negative 3. Negative 3 plus 4, positive. Negative 3 plus 2, negative. Negative 3 minus 1, negative. Negative 3 minus 5, negative. So you see, I have 3 negatives, I get a negative. Likewise, plug in 0, 2 and 6. Now go back to the question. Question is less equals 0. So I need to be negative. Okay. So I have second interval and the fourth interval, these two intervals. But notice, less equals 0, I should in theory be allowed endpoints. Why didn't I choose these endpoints? Negative 4 and 5, where did I get these from? From the denominator. The zeros of the denominator are not in your domain. The denominator, if I plug in negative 4, it will become 0 in the bottom. If I plug in 5, it will make the denominator 0. So denominator cut points are always excluded. So whether or not I am less equals, greater equals, less than, greater than, zeros of the denominator are always excluded. Zeros of the numerator are included if there is an equality here, if there is an equal symbol. All right. With that done, you have the intervals. Notice negative 2 is included, so it's filled in. 1 is included, it's filled in. Negative 4 and 5 are excluded. That's your graph. Okay. Suppose you had the question, instead of less equals, just less than. Steps would be the same. All you are looking for are negatives. Now in this case, endpoints are not included because it is a less than as opposed to less equals. It is less than. Denominators are always excluded. In this problem, even the numerator is excluded. Negative 2 and 1 are excluded because it is a less than. Graph endpoints are not included. Okay. Same question. Suppose you had greater equals. Greater equals. So endpoints should be included. Negative 2 and 1 will be included, but negative 4 and 5, because they come from the denominator, they are excluded. How did I figure these three intervals? Greater equals 0 means I need to be positive. Go back to the table. Where am I positive? My first interval is positive. Third interval is positive. Last interval is positive. So that fetches me these three intervals. Notice, because it is greater equal, the zeros of the numerators are included. Zeros of the denominators are never included. They are always open. Infinities are always open. Okay, so that is your solution set, and that's your graph. Same fraction greater than 0, because it is greater than 0, none of the endpoints are included. All you want are positive quantities. Okay, let's continue in the next video.